Well, great. It's amazing today here. Really great to hear. Let's tell a story about how we did improve performance for most of one of the most biggest
out of the teams and about 20 out of the engineers work exactly on this project I will talk today. We have 400 front-end stories for this big front-end architecture, and I will be talking just about one single repository out of this 400 today. And in total, we have 2 million.
When we talk stack,
Flutter works with Dart, right? So we use Dart and Angular. So this is a separate implementation of Angular, not for TypeScript, but for Dart. Last year, Google announced it's going to be sunset soon. So from last year, we start our transition to use that, TypeScript and React. Why I'm talking that? Because just for the context, this view, workload chart that we will discuss today, is written, yes, in that and Angular. So when we speak about Angular, when we speak about performance, we recall all the things like change detection, like on push strategy, or like some calls outside of zone. So you know, it's all about that, but not else. So what is workload itself? Um, From the product point of view, it's like pretty simple, right? So it's like a small table with some dates. You can see all the team or there, a separate view line for every team member. Inside the streamline, you can see all their tasks allocated by dates. And for each date, you have their, you believe, workload, a number that represents effort allocation for this particular day. So basically that's it. But when it comes to a real technical implementation, what we have here? First, this effort allocation. It's being calculated at both front end and back end. So you can imagine how many cells we have in front end and how many calculations we have every single time when this change detection thing is worked, right? It's getting even worse because we have this calculation for every single row. It's getting even more worse because we have some aggregations over here. For example, these two users for the Kate and Xavier, they could have some job role, for example. Let it be like front-end developer, right? And me, as a front-end manager, I want to see a workload for whole group of front-end developers. So I need some aggregation. And here is how we got this aggregation. But this is not it yet. We have another level of aggregation by projects. So you like front-end developers can work in different projects, and there's more and more and more calculators on the front-end side again. Apart from that, sure, we have infinite scroll. It's like a really fancy timeline. You can scroll to your user can scroll to any date they want. From to the past to the future, never mind. You can scroll it how you want, and you have to support infinite scrolling. You have to support paging, and you have to support recalculation on the scroll. Then, as I said, we have some optimistic recalculations and real-time updates. Just to mention, some of our customers are really big, so they could have up to 10,000 users in their accounts, or maybe even more. And when you, as a manager of some team, are sitting over here and looking into this tool, and you'll be like, interesting. What is the real workload of my team? There could be like any number of person outside of your team who really can some changes right now. They can change dates of the tasks. They can change effort allocation of the tasks. And that's why every single moment you can get an online update, real-time update from every other user in your account. And we have to apply them. And just again, it leads to recalculations. Let me catch it up. Guys, can I make it full screen? Don't mind?
Yeah.
I also?
Yeah.
Okay. Well, so we will here, right? We will have updates. Then, one more thing. If you speak about this performance, and if you speak about complexity, we have some logic around some interaction about task creation, resizing, drag and drop. Because as a manager, if you see that your team member is overloaded, you want to take this task and drag it, like to change the state. You want to replan it. This again, it leads to additional logic and optimistic calculations for all of that. So like plenty of stuff, right? And every single line here it causes a huge performance challenge. That's the challenge. Basically, it looks like that. So it's not a big deal. But if you speak about technical implementation, it is. What I will try to more about to cover today is like our journey from this year, starting from January to like nowadays in October. In January, we started having like a first huge wave of escalations that we never had before. We tried some quick fixes, we tried to set up some performance tracking, we tried some long, expensive fixes, and now I hope we can say that we almost dealt with all major problems and performance of this amazing view is good enough. So, how we even started thinking about performance, right? So, how it usually happens, in the team. You as a developer, you have a pretty small account. So in our case, it's like 5 user, 1 task. You can drag this task, fine. You can test all interactions with one single task. You can see every allocation numbers, fine. That's perfectly enough. Why do you really need in a test account really big amount of data? Like nobody does it, right? Second thing, we have pretty performance macros. So why should it be slow at all? And when customers start coming to us, we were like, but it's fine for us. Why are you complaining? It works for us. What's your case? Then a couple of other factors that the product, Wrike itself, and our workload started growing pretty rapidly. We were introducing new features over and over again, and that's how we dramatically increased our complexity, and that's how we missed some things about performance. And sure, company also it experienced some growth, and it led to the fact that we got much more enterprise customers. And who are enterprise customers? They don't have like 10 or 20 people in their teams. They have thousands of them. And they want to see this workload for the thousands of people. That sounds like a really big challenge. So starting from January, we started getting performance escalations that go 10 in January, like comparing to 0 in December. Something went wrong. If you remember some lines from the smart sheet, it looked like that. This started trying to understand what is happening, why is it happening. But like one task, performance MacBook, everything was fine. And we really didn't understand what was going on and how to fix it. So what we did, what was our case? I guess the main thing I'll try to cover today is really our experience and things that we learned. Maybe there will not be any major tricks, any major advice for you, but at least experience is, I believe, is very valuable. So what we decided to suspend all of our releases. So it doesn't matter if we release any new features if users cannot use them, right? If this tool is it cannot be opened at all. It just stuck during coding. It doesn't make any sense how my users should have. And we took one single month to focus both teams, like 2 sprints from both teams, to fix these issues or get a further more reliable plan. Our first assumptions and attempts to fix it, we were going that first of all, we started thinking about how to automate this. Like it is really crazy. When you open recommendations by Google, they said you should have around like maximum 1,500 of DOM elements in a page. We having this pretty fancy grid of data cells, especially for 4K displays or even for Full HD. We got, you see, 45,000 of DOM elements. It's done a lot, really a lot. It leads first to huge memory consumption and then to CPU consumption because every single cell it contains a number that should be recalculated. That's great. Second thing, we blamed our client-side calculations because you can see even for a really simple interaction like drag and drop, we had this optimistic scheduling of a placeholder. So you can see a task of 3 days, it jumped to 5 days because it contains now a weekend inside, right? So we have to recalculate work schedules according to weekends, according to all PTOs, like all the whole work schedules. So we started thinking about should we drop some optimistic recalculations? And then again, back to the slide. Like this is crazy. Like what would go wrong with this setup, right? And actually a plan that we got. We wanted really to understand what exactly is going on the customer edge, on the customer side, what is happening here. Because for us, it was less or more fine. We, as a development team, as a user of Workload, we used it every single day at daily stand-ups. So we experienced some minor troubles with performance, but we could use it. And it was not a showstopper for us, but it was for them. So, the first thing that we tried, we sent developers to customer escalation calls. And that's exactly how we discovered this interesting problem with spooky displays. Because from the very first segment of the school, where they started screen sharing, and we saw this huge viewport, it was pretty clear for us what was the problem. We don't have like 4K displays in or live for testing purposes, but they have it if they really want. The second thing that we did is we understood that maybe if it is fine for us, we should really track some number. We should track performance. We should set up a metric that is being calculated on a customer side. So that's how we came up with an idea of performance tracking. It's like really pretty simple. Like some code samples. As I said, we use DAP and we use Redux under the hood for state management. And we introduced a performance tracking middleware. It's like pretty simple. It's configured with these events. So as you can see here, it takes start action and finish action. In that middleware itself, we defined the most important events for users that running created a journey of user. So like a row expansion or drag and drop or scrolling or something else. And we find all events for these users. And like basically that's pretty much it about this middleware. It just start tracking when it receives start action and it ended tracking when it receives the end action. So basically it looks like that. Two timestamps, and the difference is the time of execution of this operation. And when we got the numbers of operation, what we did, we set up the metric. The metric was Apdex. Apdex is application performance index, and this is like the key thing of the whole topic, of the whole our journey about performance improvements. Apdex really helped us to understand the real picture for each particular customer, for every setup they have, maybe number of people, number of workload members, number of tasks, number of projects they explain. And how we approach it, first we prepared a list of operations, as I thought, like really major things. When users start opening workloads, like start scrolling it, doing some interactions with tasks, all those actions were included in Apdex list. Then we set start target timing. For example, I don't know, for row expand operation, when user click on like, swim lane and it should be expanded, it was maybe around 100 milliseconds. So like that. We actually did it together with our UX designers, so we could understand these two major thresholds. What is a good timing, or what is a fair and a poor timing. So like T1 and T2, it's like two borders. Then we try to understand priority considerations out of our interviews with customers, out of our own experience. We understand that the most important things were initial loading of this chart. It was recalculation, like invalidation of viewport. It was drag and drop, and it was scrolling. So we included this high priority operation into this Apdex, and it's basically how it's calculated. It's an aggregation of number of good performance events and fair performance events according to this formula, and we divide all this thing by total number of events. So as an output, we have this scale. So like everything is above 0.85. It's good. It works. It's fine. It shouldn't cause any escalations. But everything that is above that is sorry, yes, that is above 0.7, it's not good. We even if we haven't got any escalations about that, we will. I like pretty soon, and we can. We actually had some basic implementation of performance tracking for a while, for a few months, and that's how we saw our Apdex when we reviewed it. And it was really, really bad. As I told just now, like poor performance is under 0.7, right? Here you can see that it is poor. So it's not a case. It really didn't make any sense to introduce any new feature because it's unusable at all. And why should they pay us such big money for any new stuff, even when like an existing stuff, it's not working. So what we tried. In parallel, this performance tracking in parallel is like big and really expensive fixes. We started quick fixes first. So like no rocket science here. First we went to profiler, and for example, this is how looked and how looked before and after our interaction about drag and drop. So like I made a demo of this GIF with drag and drop a few slides back. That's how it works from profiler. So we eliminated some unnecessary recalculations. For example, it was pretty nice to see for yellow world tasks. In a real world, most likely customers don't have 1 year long task. It's like almost doesn't make any sense. But in testing environment, you see 1 second versus 7 seconds. It's really hard. Well, the next thing, if you guys are familiar with Redux, I'm sure you are. You know there are some practice about selectors, just to not to work with state like explicitly. And even though even if you need some calculations on why out of the state, you really selectors is exactly the thing that perfectly fits you. If you are not aware about that, like you can reach over the thing. And the thing that is makes it really faster is memoized selectors. So it uses some cache. It's a pure function, right? It gets same input, it gets the same output. So we can set up some cache so that we can avoid unnecessary recalculations here. We have this in text report. We do have this in Dark report. The only problem was that we actually didn't have the support of a deep memoization. And that's why like we don't use this thing. It's like our own wrapper of a Re-reselect library in Dart. That's published in open source and it supports e-caching. So we tried that, and it was really also useful. For example, for paragraph overwhelmed, after some change, you can see that Apdex was very significantly increased from 54 to 94%. It's like almost everything was solved, right? And another interesting chart on the right side is about pre-recalculation event. You can read it as invalidate viewport. So this is a chart for a number of this event. So you can see that before our fixes, it was a like huge amount of these events. The viewport it was invalidated for every single interaction. Now it's not, and it became really much more faster. And then finally, like the most expensive and most interesting stuff, because even though we introduced all these changes, it didn't help a lot. It added maybe, I don't know, 3, 4, 5 points into our Apdex. So it wasn't a solution. We still were in like fair performance mode. So our plan was the following. We understood that our product is complicated. Maybe we can challenge this business logic and we can get rid of some things. The second part of this plan was to introduce some expensive technical improvements that we already understand that we have to use it finally. So, getting to examples. This example I really love it. What is it about? We have at the bottom of the chart we have a backlog box. So, like, how does backlog box work? Like in any product, it has some unassigned tasks. So, you as a team, as a manager, or as whoever, you can go to your backlog and assign tasks to people. And our initial logic, our initial idea was to have this backlog box have all the tasks from the account. And it was exactly what customer wanted. It was exactly what they asked for. But there was a little problem when we came to enterprise customers, right? Because it worked fine when they had some 20 users in account. When they had 10,000, okay, fine, cool. We are generating a lot of stuff. It became a problem. So, what we tried? We tried to use this logic and display the backlog box just the task from the scope of the chart. Like it's a major change, like change of logic, change of what customer asked for. But it worked. It worked perfectly fine. Yeah, it was. Helped a lot with the backlog itself, and it's also been validated with customers, and they were perfectly fine with the change. So, why I love this example? Nothing is set in stone. You can really change things even outside of technical improvements, pure technical improvements. I mean. Another experiment that we have, this is an experiment. This was released by Wrike. We understood that our scroll is really heavy. It was heavy. We understood that it was about, it was because we had to recalculate a lot of stuff during scrolling. So an idea was pretty simple. Unit scrolling, please scroll. You will not see any data, but it will work much faster. So, like in a really couple of days, we implemented this experiment. We released it under some beta flag, and we enabled it for several customers who had the biggest complaints about scrolling experience. And it was interesting. They said that yes, scroll works fine now, but we do need these tasks because we don't just scroll to any day. We have no idea about dates. We remember that they had some tasks somewhere, and we're really seeking for these tasks. So we have to see these tasks. It was sad, but finally we finished this experiment. It was not released. Another experiment was about alignment dates. I already tried to introduce this logic, so how it works. You sit in your chat and you have 10,000 of your colleagues who are making changes into these tasks. And all these numbers of the tasks, they are getting more and more updates over and over again, and everything has been recalculated. And our hypothesis was that why do we really need this? Our experiment was about getting rid of this alignment dates at all. But what we did, we introduced this refresh button, that actually can get your update picture like in any time you want. So if you want to just go into the chat and get a weekly report, you don't need all this real-time updates. You can use this refresh button. And we, in our own account, we also have pretty much users. So what we did here, we deployed, enabled this feature for our own account, and after that we tried to generate this online updates by ourselves. So we collected a team of like a lot of people, and we assigned one person who was sitting and clicking this refresh button, pretending to be a user of Workload, and who also was measuring performance of all interactions. And all others were like just dragging tasks like crazy and generating a huge amount of updates. And it showed us that it was not the case, actually. If the chart is properly set up, if a viewport this just for some particular days, it doesn't make any sense what is happening in other parts of the viewport that are out of screen. It doesn't make sense what's happening out of the chart scope, so it worked perfectly fine, and we also used this experiment. But it was interesting. And like my favorite thing here, when we started Workload 3 years ago, we aimed to support like infinite growing, so horizontal virtualization, and also vertical virtualization, so that we could display like hundreds of users, really hundreds of users. And it worked perfectly fine until we got this nested rows, until we got hierarchy. I don't know why, like nobody does, but we made really simple mistake. We forgot to support this virtualization for nested rows. And look how it worked. In a report, there was a user with like 51 project handlers. 51 project handlers this user. And vertical virtualization, when it comes to it took these rows and said, okay, I have one single row of user, I will show it like the whole row. And it rendered all 51 of nested projects. 51 rows of nested project means that it's a huge amount of cells that should be calculated, a huge amount of tasks that should be requested, and it ruined everything. So instead of 5 projects, we showed 51. It's like an edge case, it's a test requirement, but anyway, in customer accounts, it also could be a case. For example, we have some customers who have they have a separate project for every single, how to say it, every single deal. So when their own customer came to them, and when they have a deal, they have a small, tiny, really tiny project for that. So they have like hundreds of such projects, and that's why it failed. And actually, yes, yes, like 2 more minutes. Thanks. Actually, it works perfectly fine. So here are like a list of what we tried, like quick fixes, long fixes, experiments, changes in product logic. You see, if you can see scroll, it's like half of this list, so it was really a huge amount of things. And as a result, what we got during like over a couple of months, our performance became at least fair, and it went to even some good state, like more than 0.8. And at the bottom chart, you can see that green line, for example, is Apdex for a peak account, and it was really pain in January, but it became much more better now. So it's like basically steps for our events. You can see we have a lot of events above 0.9, but we still have some troubles with several events from this list. And what is next? Just want to share our future plans, but really want to ask, what do you guys think? Like any random ideas, what is the most performant tool in the world?
Use canvas instead of Tom elements.
Kind of, but yeah, you're right. I said, what is, I'm asking about a tool. What is the most performant tool application in the world? How do you think?
Say random.
Excel, for that Excel. Yes, so yes. Cool. Yes, it is Excel. And if you guys, if you ever tried to look how Google spreadsheet is unrealized, they use canvas. So they have the same crazy grid, like huge amount of cells, huge amount of everything. But they use canvas and it works perfectly fine. So our next plan is to switch from DOM to canvas. Yes, exactly as you said. And also leverage Excel in other way. We will just export this data to Excel and let them slice and dice this data as they would. Because it's really impossible just to cover some edge cases with huge account and huge setups. So here's the report to the article about this talk. If I didn't cover anything, so you can find details there. And also you can post your questions as comments. I'm sure I will answer. And like as an outcome of this call, of the talk. So what if I did this again? How I will avoid it? That. Sure, I will start from the profile and check GPU and memory consumption and deep inside. Check my DOM nodes counter and make sure it doesn't exceed 1,500 of DOM nodes per page. I will try to set up a performance tracking and updates to understand the real picture from customer side because I can have a good performance manual, but they don't. And if I use Redux memoizing selectors, I won't be afraid to run any experiments with features, to get rid of them, simplify features and business logic. For any detailed layouts, I will use Canvas instead of Zoom, sure, instead of Zoom, no. And like as a wish, I would say I wouldn't build any universal tools anymore. It's impossible to cover everything in one single tool, but really it's better to limit yourself to some particular cases and make sure they will work perfectly fine. That is it. Thank you very much, guys.